Quartile measures are another way of summarizing and organizing your data that can tell us about the distribution of our data. Quartiles actually split the sorted data into 4 segments or partitions with an equal number of values per segment or partition. So the first thing that you need to do is to sort your data in an ascending order, smaller to the largest. And after you do that, you have to partition them into equal segments, 4 equal segments, 4 partitions, such that 25% would fall in the first partition or first segment, 25% would fall here, 25% would fall here, 25% would fall here. And these are sorted data. So the value that is, for example, here is greater than 25% of these data here. The value that is here is greater than 50% of the data here, and so on and so forth. So we actually call these quartiles, and quartiles come from the quarter because it divides by 4. As you see here, we have 4 segments. So that's why each of these is called a quartile. This is the first quartile. The first quartile. This is called the first quartile, the second quartile, and the third quartile. It's just the quartile is just a number here, any number here, that would say, okay, for the first quartile is 25% of your data is smaller than the first quartile, and 75% of data is greater than the quartile, right? For the second quartile, 25% of data are less than the second quartile, 25% are greater than the second quartile. For the third quartile, only 25% of your data are greater than the third quartile, and 75% of your data are smaller than the third quartile. We actually call the second quartile the median, if you remember. So median is the middle number where 50% of your data, half of your data, 50% is greater than the median, and half of your data is less than the median, right? So the second quartile actually is the median in your data. So how to locate quartiles? How to find the first quartile, Q1, the second quartile, Q2, and Q3? Remember we had a formula for finding a median, or which is Q2. How about finding a formula for Q1 and Q3 as well? So this is what we want to do. We want to find a quartile by using a formula. So first you need to rank your data, order your data from the smallest to the largest. The formula for the first quartile, the location of first quartile, location or position of Q1 is n plus 1 divided by 4. N is the number of data value that you have. So this is going to give you the location, the position of your first quartile. For Q2, we already know that, that's the median. So that would be n plus 1 divided by 2, which is actually 2 multiplied by n plus 1 divided by 4. I can actually write the first formula like this. So this is the first quartile. So that would be 1 multiplied by n plus 1 divided by 4. For the Q2, the second quartile, it's 2 multiplied by n plus 1 divided by 4. And you can guess it for the third quartile, right? The third quartile, the formula would be 3 multiplied by n plus 1 divided by 4. So these are going to give you the positions for the quartiles. I'm going to get rid of these lines and show you the formula. So For the first quartile, the formula for the position of the first quartile is n plus 1 divided by 4. For the second quartile, we already know that it's n plus 1 divided by 2. You can write it as 2 multiplied by n plus 1 divided by 4. And for the third quartile is 3 multiplied by n plus 1 divided by 4. N here is the number of data points that you have, or observed values that you have. Quartile measures calculation rules. Remember we had a rule in finding the median using the formula n plus 1 divided by 2 to find the position of the median. We had different rules if n was odd or n was even, right? We actually have similar rules for computing and finding Q1 and Q3 as well. Let's see those. When calculating the ranked position, that means that you have ordered your data from the smallest to the largest, you want to find the position, the location of your quartile. If you use the formula and the result of the formula is a whole number, for example, you want to find the position of your first quartile. You use the formula n plus 1 divided by 4. You have ordered your data first from the smallest to the largest, right? And suppose this is a whole number. For example, 3 is a whole number, 5 is a whole number, when it doesn't have any decimals. So when it's a whole number, then that's going to give you the position of the quartile. So the first number, the second number, the third number. So this is the third number is your quartile. If the results of the equation or the formula is a fractional half, such as 2.5, 7.5, 8.5, it has a half, 0.5, then average the two corresponding value, similar to the n plus 1 over 2 for the median formula that you have. So for example, you want to find, I'm going to go with Q3 this time. You want to find the position of your third quartile. This is 3 multiplied by 3 multiplied by n plus 1 divided by 4. Suppose this is a fractional half, 2.5, and you have ordered your data from the smallest to the largest. So 2.5, this is the first number, the second number, the third number, and the fourth number. 2.5 is between 2 and 3. So you have to find the average of the second number and the third number. The average of this second number and third number is your quartile. Let's look at the last rule. If the result of the formula is not a whole number or a fractional half, then round the result to the nearest integer to find the ranked position. I'm going to go with another example. So suppose we want to find Q1, for example. You use the formula n plus 1 divided by 4. Suppose it's a number that it's not half and it's not a whole number. For example, 2.3. What is the closest nearest integer number to 2.3? We have to round it down because 2 it would be the closest value. So the second number in your sorted numbers, the second number would be your first, second. So this would be your quartile. If it was, for example, suppose it was another number. Suppose it was 3.8. The closest number, whole number or integer number to 3.8, you have to round it up, is 4, right? So the fourth number would be your quartile. First, second, third, and fourth. The fourth number would be your quartile. Let's do an example and find the quartiles for a set of data. Suppose we want to find the quartile, the first quartile, second quartile, and the third quartile of the following set of data. Please pause the video, work on the example, and then come back to see the solution. Okay, let's do the example. First of all, what is the first step to do when you want to find a quartile? First step. Order your data from the smallest to the largest in an ascending order. Luckily, our data here are actually already ordered from the smallest to the largest. So we are good to go with that. We don't have to do that step. What next? We want to find, for example, the Q1, the first quartile. Let's see how many numbers we have. 1, 2, 3, 4, 5, 6, 7, 8, 9. So n, the number of data that we have, is 9. We have ordered the data from the smallest to the largest already is ordered. So we can find the position for Q1. Q1 position. What was the formula? It was n plus 1 divided by 4. N is 9, so that would be 10 divided by 4, which is 2.5. So we have a half number here, 2.5. According to the second rule that we had before, we have to find the average of the second number and the third number. First, second, third. 2.5 is between second number and third number, right? So we have to find the average of 12 and 13. So Q1, our first quartile, is equal to 12, the second number, plus 13, the third number, divided by 2. This is the average of the two, which is 12.5. So 12.5 is our first quartile. All right, let's see. We have 9 numbers, and the first quartile position is 2.5, and that would be 12.5. Okay, let's now compute the second quartile. So we want to compute the second quartile. Q2 position, which is also the median. Q2 position, we have to use the formula n plus 1 divided by 2. N is 9, so that would be 10 divided by 2, which is 5. So the fifth, this is a whole number. Because it's a whole number, that means that that's the position of our second quartile. The first number, second number, third number, fourth number, the fifth number. 16 is our quartile. So Q2, the second quartile, which is also the median, is equal to 16. This is our second quartile. All right, now let's find the third quartile. To find the third quartile, the position of the third quartile would be using the formula 3 multiplied by n plus 1 divided by 4. That would be 3 multiplied by 10 divided by 4. 30 divided by 4, which is 7.5. So 7.5, we have to find, this is a half number, we have to find the average of the seventh number and the eighth number. This is the sixth number, the seventh number, and the eighth number. So the average of 18 and 21 would be our third quartile. Which is 19.5. All right. There is another quartile measures that is called the interquartile range, or IQR. What is IQR? IQR is actually the third quartile minus the first quartile. which covers the mid 50% of your data. That's why it's called the mid spread, another name for IQR. Let's go back to the definition of the quartiles. So we said that quartiles is when you order your data from the smallest to the largest, and then split them into 4 equal segments or partition. First, second, third, and fourth. This segment covers 25% of your data. The next covers also 25% of your data. So they include equal size of your data. And we know that this is our first quartile. This is the second quartile or the median, and it is the third quartile. Okay. So Q3 minus Q1, this actually range is called IQR, which, as you see here, covers 25% plus 25%, which is 50%. So it covers the mid 50% of your data. That's why it's called the mid spread. What is IQR is used for? IQR is a measure of variability that is not influenced by outliers. It's not influenced by outliers or extreme values. That's a good news about IQR. So it's a measure of IQR is a measure of variability as well. Measures like IQR, Q1 and Q3, the third quartile and the first quartile as well, these are not influenced by the extreme values, and they are called resistant measures. Those measures that are not influenced by the outliers are called resistance measures. Q1, the first quartile, and Q3, the third quartile, these measures, they are measures of non-central locations because this is the first quartile and the third quartile. So they are in the other side, the left side and the right side of your data. They are non-central location. Q2, however, the median, is a measure of central in tendency, as you know that, right? So the measures of central tendency, we learned about 3 of them: the mean, the median, which is Q2, and the mode. Q1 and Q3, on the other hand, they are not measures of central tendency. They are non-central location, or the variability measures. Let's work on a practice problem. We want to find the quartiles and the IQRs for the following set of data. So we want to find Q1, Q2, and Q3 and IQR for this set of data. Please pause and work on this problem, find the quartiles and the IQR, and then come back to see the solution. Okay, what is the first step to do in finding the quartiles? We need to order our data from the smallest to the largest. So let's do that. Order our data. All right, we ordered our data. How many data points we have? We have to count them. We have 14 data points. So let's find the Q1, the first quartile. The formula for finding the position of the first quartile is n plus 1 divided by 4. So that would be 14 plus 1 divided by 4, which is 3.75. We have to use the third rule. The nearest integer number to 3.5 is 4. So the fourth position for the fourth number is our first quartile. The first number, the second number, the third number, the fourth number. So our first quartile is 15, right? Let's now find the second quartile. The formula for second quartile is n plus 1 divided by 2. 14 plus 1 divided by 2 is 7.5. So we have to use the second rule. We have to find the average of the 7th number and the 8th number. The 5th number, the 6th number, the 7th number, and the 8th number. 7.5 is in the middle of 7 and 8. So we have to find the average of 24 and 35. which is 29.5. So that's our quartile, second quartile. Let's find the third quartile. The formula for finding the third quartile is 3 multiplied by n plus 1 divided by 4. So that would be 11.25. So we have to use the third rule. The nearest number to 11.25, the nearest integer is 11. So the 11th number would be our third quartile. The ninth number, the 10th number, the 11th number. So 49 is our third quartile. Now let's find the IQR. So IQR is the third quartile minus the first quartile. The third quartile is 49, the first quartile is 15. 49 minus 15 is 34. So IQR is 34 here. Okay.